Hi everyone, welcome to my channel Triple Encyclopedia, and in this video let us see why Thevenin's theorem is most commonly used method for analyzing a complex network and instead of using the normally available methods. So now let us see. So the commonly available methods for analyzing any electrical network is the Mesh Analysis, Nodal Analysis and Kirchhoff's current circuits law. And if you are using these generally available methods, suppose if the load on the DC power network changes, so depending upon the changes, again and again we want to recalculate the value of current or voltage across the particular load resistances. But instead of performing the recalculation again and again, we can simplify the part of the network, complex network, into a simple network, and end of the simple network we are going to connect the load. That is, we can connect any values of load at that end of the simplified network, and the calculation may be simplified. So for that purpose the Thevenin's equivalent circuit will be used. So now let us see with one example. So consider this is the circuit. For this circuit, we want to calculate the value of current or voltage across the load resistance 5 kilo ohm. Suppose you are using the normal method depending upon the value of load. Suppose I am connecting the 5 kilo ohm resistance. Now I am going to apply the Mesh analysis, means I want to construct the matrix, and from the matrix we can easily identify what is the value of current in that particular resistance RL. Suppose the load resistance may be changed from 5 kilo ohm to 10 kilo ohm. So again we want to apply the Mesh analysis, that is, we want to perform the calculation for the whole circuit again. So once the load resistance is changed, depending upon the value of load resistances, again and again we are going to perform the calculations from the beginning itself. That may be this is simple network. Suppose we are taking the complex network, that calculation that is not much easier. So that what we are going to do is we are applying the Thevenin's theorem. So in the Thevenin's theorem, so this network, right, this is the one complex network. So this network is normally having only one voltage source and three resistances. But instead of this simple network, suppose we are having a network with two voltage sources and more number of resistances. At that time, just we are applying the Thevenin's theorem by removing the load resistance. So after removing the load resistance, this part of the network only considered for constructing the Thevenin's equivalent circuit. So in this network, suppose I am having the two voltage sources, means that may be simplified into single voltage source VTH, and series with this voltage source I am going to connect the internal resistance, that is called Thevenin's resistance. That is, this complex network is simplified into single voltage source series with the internal resistance. So this network or this circuit is called as the Thevenin's equivalent circuit. So suppose I am going to calculate the value of current flowing through the resistance RL, means at the end of this Thevenin network the load resistance will be connected, and just we are applying the Ohm's law, and we can get the value of current flowing through the resistance or voltage across the load resistance RL. Each and every time the load may change depending upon the value of load. Just I am going to connect the load resistance at the end of the Thevenin's equivalent circuit. So this part is calculated, that this part is simplified only once, right? Only load resistance will be changed. So in the previous cases, if the load resistance is changed each and every time, again we are going to perform the calculations from the first loop and second loop, like that. But here this part is once simplified, so after simplification only load resistance will be changed and the corresponding value of current and voltage across the resistance will be calculated. So this Thevenin's theorem is invented by Léon Charles Thévenin. He is a French telegraph engineer, and this theorem states that any linear circuit, so this theorem is only applicable for linear circuit, non-linear circuit this theorem is not applicable. So for a linear circuit that may be contain several EMF and resistive component, it means this circuit, right, this is the complicated network. This network is having the only one voltage source. Instead of that we are having the more number of EMF or voltage sources and more number of resistances. So this type of linear network is replaced into a voltage source, single voltage source, and it is having the resistance in series with it. So voltage source with a series resistance, that is called the Thevenin's equivalent circuit. That is, any complicated network is modified or simplified into a Thevenin's equivalent circuit. The Thevenin's equivalent circuit is voltage source series with the resistance, and here we are going to connect the load resistance, and after connecting the load resistance, we are applying the simple Ohm's law, and we can get to the value of current or voltage across the load resistances. So this is some basic information about why Thevenin's theorem is preferred for analyzing the complex electrical network. So steps to calculate or to get this Thevenin's equivalent circuit I am going to explain in my next video. Thank you for watching. If you are new to this channel, kindly subscribe our channel AAA Encyclopedia, and share all basic concepts of this channel to your friends also.